Welcome to the GCSE 2022 paper, and this is paper 1, the last question, which caused a lot of problems. Now, there's three basic things you need to know in order to solve this question. So you had to find the area of the green bits in this diagram, okay, in terms of pi. Now, what you need to do first is find the area of three parts. The circle, which I've called C, that's one complete circle, the triangle T, and one of the segments, that's the bit I've shaded in yellow here. If you know the areas of those parts, you can combine them in lots of different ways to get the required area. So what I'm going to do is work out those three distinct parts first of all. So C is easy, that's just simply pi times the radius squared, which is pi times 4 squared, okay, and that is equal to 16 pi. Okay, second thing, the triangle. Now, one of those triangles, T, is an equilateral triangle. Now, it's easy to see why, because if we took the center of, say, circle B, we can see that that line is 4 and that line is 4 because they're both radii of the same circle. If we took this point A, we can see that that's also 4 and that's 4 because they're radii of the circle on the left. So basically all of those lines are 4 centimeters, so they're all equilateral triangles. So T has an area which is a half AB sine the angle between them. Well, the angle is 60 degrees and A and B are both 4. So it's a half times 4 times 4 times the sine of 60 degrees. Now, you should know the exact sine of 60 degrees is root 3 over 2. And so that actually comes to a half of 16, which is 8, times root 3 over 2, which is 4 times root 3. Okay, so that is the area of the triangle T. And we then have the segment S. Now, the segment S can be made of the sector, okay, which is 1/6 of the area of the circle. Okay, and if I put the 60 degrees in there, you can see that that's 1/6 of a total circle of radius 4. So the sector area is 1/6 of the circle C, okay, minus the triangle T. And that would give us the yellow bit that's left over there, you see. Well, we've already worked out C and T, so we just need to substitute to find the what's left in terms of pi. So 1/6 of C is 16 over 6 pi, okay, because we've got 16 pi here. If we divide that by 6, we get 8 pi over 3, okay, and the triangle T we've just worked out to be 4 root 3. So that expression there, 8 pi over 3 minus 4 root 3, is the same as the area of that little yellow piece there, which I've called S. So that's one result. That's the triangle and that's the circle. Now, I just need to combine them appropriately to get this. Now, if I took the triangle I've drawn here, you can see that if I took one of the segments away from the side here and stuck it up there, that's replacing like for like. And it just leaves me then with one more segment to subtract from the triangle. And because I have two of those green bits, top and bottom, I just double it. So the green area, and I'm just going to call it green. So the green area is simply going to be 2 lots of the triangle minus one of the segments. Okay, and I just need to put the numbers in. So that's simply 2 times 4 root 3, okay, minus a segment. Now a segment is made of 8 pi over 3, okay. Now you have to be careful here. It's 8 pi over 3 minus 4 root 3, okay, but because of the minus sign in front, it's going to be minus 4 root 3, which is plus 4 root 3. Okay, so just be careful with that. Now, if you multiply that out, you've got 4 root 3 and another 4 root 3. It's 8 root 3. Multiply everything by 2, and that simplifies to give me 16 root 3. And I've also got 2 lots of 8 pi over 3 to take away. So I'm taking away 16 pi over 3. Okay, and that's the answer to the problem. There are lots of ways you could work that out once you know those key bits of information there. Okay, and you recognise that this is an equilateral triangle. Okay, hope that was helpful. Take care.